Okay, a lot of this is going to be revision from year 10. You've seen all of this before. Potentially you might have done some of this in Key Stage 3. So we're going to talk about the metals. First, let's just remind ourselves of their properties. Okay, so you can use arrows or highlighting to link the properties listed here with either metals or non-metals. For example, strong under tension and compression, well, you would say that was metals. Malleable, metals. Low density, non-metals, etc. Stop me now and work through the list. Right, we're back. These properties can be either physical or chemical. All of these here are physical apart from 4 of them. There's 2 for the metals and 2 for the non-metals. So which are the chemical properties here? Now remember, chemical properties are to do with how things react, often to do with how they exchange electrons. So what are the chemical properties? Have a look through. Okay, for the metals, metals form positive ions when they react. We saw that in the last section. And they usually form basic oxides with oxygen. Remember, basic oxides, they react with acids. So for example, magnesium will form magnesium oxide with oxygen, and magnesium oxide is basic. It will react with acids. Non-metals can form negative ions. Sometimes they form covalent bonds, but they can form negative ions when they react, and generally they will form acidic oxides with oxygen. So they'll react with bases. For example, sulfur will produce sulfur dioxide. It's an acidic oxide, which will react with bases to form salts. Okay. The other 2 versions of oxides, remember, were amphoteric, which react with both acids and bases, and neutral, which don't react with either acids or bases. The reactivity of the metals, we can use some other substance to react with the metals to see how violently or to what extent that substance reacts with a particular metal. Okay, so what we typically use is water and dilute acid. So with water, if we put the metals in water, we can observe what happens, we can look at the products, and we can try to put the metals in some kind of reactivity series. Okay, so here, what have we got? Well, we've got reactions with water. Potassium, it reacts violently with cold water and floats and catches fire. And if you look at the statements here, then they get less and less reactive as we go down. Now, potassium and sodium react quite vigorously. Calcium less vigorous. When you get to magnesium, this is kind of a cutoff point. It reacts very slow with cold water, but it reacts vigorously with steam. Okay, so we have to heat the water up, make steam, and magnesium reacts vigorously. There's a difference in the products. When something reacts with cold water rapidly, a hydroxide is formed. But when you need to use steam, an oxide is formed. Something for you to note. When you write the equations, obviously you need to know what the products are. And then when we get down the bottom of the reactivity series, copper does not react with steam even. Have a go at writing the reactions for the elements that have got an asterisk. Okay, so the sodium reacting with water, it produces sodium hydroxide and hydrogen gas. We need to balance this equation. And put in a 2 in front of the 3 chemicals makes the whole thing balance, I think. Double check it. And then zinc reacting with water. It's a bit easier to balance. It produces zinc oxide. Notice that the water is gaseous because it's steam. And iron reacting with water, again, gaseous, produces iron oxide and hydrogen. We can also see how these metals react with dilute acids. So, for example, magnesium will react vigorously and you get a stream of gas bubbles evolved. Obviously, magnesium reacting with an acid produces, if it's hydrochloric acid, a salt, magnesium chloride, and hydrogen gas. Zinc reacts quite slowly. Iron is a relatively slow reaction. Lead very slowly. The acid must be concentrated. Chlorides are formed in each of these cases, and copper does not react with dilute hydrochloric acid or even concentrated hydrochloric acid. Have a look at these three metals and try and write the equations for the reaction with hydrochloric acid. Okay, there's the equation for magnesium. It needs to be balanced. And a 2 in front of the HCl does the trick. For zinc, same balancing, same valency. And for lead, same balancing because it has the same valency. There's one slight difference in the lead and hydrochloric acid equation. What is it? Can you spot it? The lead chloride that's formed is solid. You get a white precipitate because lead chloride is insoluble in water, isn't it? Okay. And then B, nota bene, more reactive metals can react with acid explosively, so we don't even put sodium or potassium into acid. Right, some extra notes about metals and their reactivity. Aluminium is a reactive metal, but it doesn't really do what we expect it to do. It doesn't appear to be reactive, and we have to work out why. And the reason is that aluminium quickly forms an oxide layer of aluminium oxide on its surface. And that aluminium oxide layer, it prevents further reaction. And it stops the aluminium reacting with, for example, dilute hydrochloric acid even. It reacts very slowly at first while the oxide layer is dissolved. So it apparently is much less reactive than it actually is. Another similar example is sulfuric acid reacting with calcium. Calcium will react very vigorously with hydrochloric acid, and it reacts vigorously with sulfuric acid at first, but then once the calcium has been in contact with the sulfuric acid, what happens is a layer of calcium sulfate forms on the calcium. And that layer, because calcium sulfate is insoluble, as you know, that layer prevents further reaction. So there's a rapid reaction at first, but then the reaction stops. Okay? That's how it works. These are similar situations. I mean, slightly, obviously this is with sulfuric acid, and this would just be with the air. It forms an oxide layer, but they both prevent further reaction. Okay, have a go at essential chemistry on the pages indicated.